Hello everyone, this is Balu. Welcome to my channel Civil. Now let us solve the previous AEE questions that is asked in 2023 question paper on hydrology and irrigation. Coming to the first question, it is given as field capacity of a certain soil is 20%. Let us write the whatever the given data, that is field capacity is equal to 20% and specific gravity is 1.6, that is G is equal to 1.6. Before applying irrigation water, a wet sample of soil was taken and its mass found to be 150 grams. After oven drying, its mass was 136 grams. Mass of wet sample is nothing but 150 grams. Mass of dry sample is nothing but 136 grams. Let us find the optimum moisture content or moisture content. Moisture content is equal to 150 minus 136 by 136 into 100. It is nothing but weight of water by weight of solids. That is nothing but moisture content. You will get approximately equal to 10%. That is 14 by 136. It is nearly 10% you will get. Next, what the question is asking is, determine the depth of water that must be applied to irrigate the soil to a depth of 0.9 meter. He is asking the depth of water required. Okay, we all know that depth of water which is required is depth of water dW is equal to SD into field capacity minus optimum moisture content. Where S is nothing but specific gravity, here I wrote G, whatever it may be, and D is the depth of root zone. Here depth of root zone is given as 0.9 meters. Now let us write this 1.6 into 0.9 into field capacity is nothing but 20 and optimum moisture content is 10%. This is in percent, let us divide by 100. 1.6 into 0.9 into 1 by 10. You will get approximately 144 mm. Directly it is like 69 is 144. But here nearly you have the option that is 140 mm. So this is the right answer. Next, coming to the second question. The 3-hour unit hydrograph of a basin can be approximated as a triangle with a base period of 20 hours and peak coordinate of 300 meter cube per second. The area of the basin. Okay, he is asking the area of the basin, and here he is given as unit hydrographs. So unit hydrograph means 1 centimeter depth of runoff. Now let us draw the graph. You can solve directly, but for explanation I am drawing the graph. It is given as 20 hours. This is the base period. Here is T, which is in hours, and Q, which is discharge in meter cube per second, and the P coordinate it is given as 300. If you multiply or if you find the area of this triangle is nothing but area is equal to half into base into height, that is 20. It is given as hours. So let us convert into seconds. 60 into 60 into 300. Okay, if you multiply meter cube per second into hours, like just observe the units, meter cube per second into seconds, you will get second cancel, you will get the meter cube. But here he is asking the area of the basin. Meter cube means which is volume you will get here, but you have to divide by depth so that you can get the area. Just follow the logic. Don't remember like formulas wise also you don't have to remember. You can directly come with the logic of units. It is divided by what is the depth of unit hydrograph. It is nothing but 1 centimeter. So let us write it in meters. 1 centimeter means 10 to the power minus 2 meters. Now 1 ja 2 10 ja 6 ja 36 36 3 ja 108. Just in numerator only, if you multiply with 6 ja 36, let us remove that whatever the 10 to the power something you will get. 6 ja 36 36 3 ja 108 you will get. If you see the option, The options are like you can see 108 here only. You can directly pick here. You don't have to solve like what is the 10 to the power, what will you get. Approximately, you can directly round up with the numbers whatever available here. Whatever the 10 powers will be there, you can directly neglect it and you can find the options. Based on the options, you can proceed. Next, coming to the next question. The circular dug well in fine sand region has a yield of 15 liter per second. Okay, it is given as yield, that is nothing but discharge 15 liters per second. Let us convert it into meter cube per second. It is nothing but 15 into 10 to the power minus 3 meter cube per second. Under a depression head of 4 meters. So it is head is given as 4 meters. 4 meters. Assuming specific gravity per unit area as 0.8 per hour. Okay, it is given as C. Specific capacity per unit area as 0.8 per hour. This is 0.8 per hour. The bottom diameter of the dug well is asking the what is the bottom diameter. For a dug well, we have a formula that is Q is equal to C into A into H. Where C is the specific capacity per unit area and A is the area and H is the depression head. Now let us find out the diameter of the dug well. Let us substitute the values. That is discharge is nothing but 15 into 10 to the power minus 3 is given, and C, that is 0.8. We have to convert this per hour to second, that is 60 into 60. We have to find the area, that is pi by 4 into d square, that is we have to find the diameter from this area expression, into height is nothing but 4 meters. Let us find the diameter. Okay, let us neglect whatever the 10 to the power terms and directly approximate the diameter. We will get like I'm writing here. We have 6. Let us cancel this 4. 6 yeah, 36 into 15. Let us write this as 8 directly here. Now I am taking pi as 22 by 7. If you write here 7 by 22, it will come approximately 8 1 ja, 8 2 ja, 2 1 ja, 2 11 ja, 11 1 ja, 11 3 point something it will come. 7 3 ja 21. That is approximately you can get root over 22 like that. Root over 22 is lies between 4 square and 5 square. That is here we have d square. We have to find the d. That means approximately the value is between 4 to 5. You can see the options here. That is 4.64 is the between value in between 4 and 5. That is 4 is the option 4 is the right answer. Let's come to the next question. The silt factor F as used by Lacey's in his regime theory was adjusted to be equal to 1. F is 1 given in the question. In an alluvium region, what is the median size of the alluvium soil? Soil particle size is asking. We all know that for the Lacey's regime theory, it is 1.76 root over d50. This is d50 is the particle size, and here F is given as 1. 1 is equal to 1.76 root over d50. You can square on both sides. That is d50 is equal to 1 by 1.76 whole square. We will get this as approximately 0.32 m. Where here d50 is in mm only. This is the empirical equation. Let's come to the next question. Analysis of data on maximum one-day rainfall depth at Hyderabad showed that a depth of 300 mm had a return period. Return period is nothing but T is equal to 80 years. The probability of a one-day rainfall depth equal to or greater than 300 mm at Hyderabad occurring at least once in 80 years. You all know that occurrence of rainfall at least once is given by the expression that is 1 minus q power n. The occurrence of rainfall, not at all occurring of rainfall, is given by q power n. At least once means 1 minus q power n. 1 minus p whole power n. 1 minus 1 by t whole power n. Here n is the number of years and t is the return period, that is given in the expression 1 minus 1 by 80 whole power 80. It is very difficult to solve in hand, so approximately you can get this value as 0.64, which is not given in the question. Okay, let's leave it. But in the previous year question also you can see the same type of question, but in that it is 100 years is the return period and at least occurring once in 100 years. For that question also it is answer is 0.64. So please remember this 0.64 value, so that if you get in upcoming exams you can directly keep this 0.64 as the option if you have, because it is you can't solve directly with the hand, so that's why I am telling this value to remember. Coming to the next question. Depth of score according to Lacey's formula in a river represents the depth below the, this is maximum depth of score in the channel. This is the option. Next, coming to this question. If duty is 1500 hectare per cubic, duty is given as 1500 hectares per cubic, and base period B is equal to 150 days for an irrigated crop, and he is asking about delta. We all know that D is equal to 8.64 B by delta. In this expression, D is in hectare per cubic and delta is in meters and base period is in days. Now let us find delta is equal to 8.64 into 150 by 1500. You will get this as 0.864 meters, which is nothing but 86.4 centimeters. It is given in the first option directly. Let's come to the next question. A tube well commands 20 hectares of land under rise. The area is given as 20 hectares. When the well is discharging at a constant rate, the water level in the well drops to 120.2 meters. The level of highest land is 129 meters. So delta head, that is head difference, is nothing but 129 minus 120.2. You will get 8.8 meters. The duty of rise is 800 hectare per cubic. Duty is given as 800 hectares per cubic. For the pump efficiency, it is given as 60%, that is nothing but 0.6 you can take. Input power of the pump is, he is asking about input power. You know that efficiency is equal to output power by input power. Output power is given as gamma Q H. This is a basic formula. This is input power. And substitute in this expression. For input power, gamma is nothing but 1000 into Q. For Q, here you can see this is 20 hectares. This is 800 hectares per cubic. If you divided A with D, you can see the units also. Hectare by cubic, you will get cubics. So I am dividing here 20 by 800 into height difference, that is 8.8 meters. And efficiency is 0.6. You can substitute here. To 1 ja, to 4 ja, you can see 2.2. If you see here, like 6 will go up, 2.2 into 6, 60. Roughly it is 2.2 by 6. That is nothing but like 6 3 18 3.5. In this way you can get answer. So that is 3.59 kilowatts. Like just I am taking all the whatever the numerical terms only, because if you directly neglect the 10 to the power terms, because to get the answer this is the fastest way, so that you can neglect the 10 to the power terms. Let's come to the next question. What will be the depth of downstream cutoff wall if maximum static head, length of floor and safe exit gradient is 2.4 meters, 21.45 meters and 1 by 5 respectively? So you all know about the exit gradient formula, that is E is equal to h by d into 1 by pi root over lambda, where lambda is equal to 1 plus root over 1 plus alpha square by 2, where alpha is nothing but b by t. Here b is given as 21.45 meters and we have to find the d. H is nothing but 2.4 meters and exit gradient GE is equal to 1 by 5 respectively. If you substitute all these values in this expression, you will get d value. I am not solving this question because it is very difficult to solve. With hand calculation you can't get this answer. You have to use calculator. That's why I am not solving this question. Next, coming to the instantaneous unit hydrograph is a hydrograph of. Here unit hydrograph means it should be unit depth of rainfall, like unit runoff excess. Here you can see unit rainfall excess, it is directly given, and also instantaneous means infinitely small duration. So you can pick this option. This is the right answer. Next, coming to the next question. For a catchment S curve due to a rainfall intensity 1 cm/hour is given by Q is equal to 3 minus of 2 plus T. The expression is given and T is in hours and Q is in meter cube per second. At T is equal to 1 hour, ordinate of instantaneous unit hydrograph is asking. We all know that ordinate of instantaneous unit hydrograph is given by 1 by I into ds by dt, where ds by dt is the slope of the S curve. Slope of S curve, where I is the intensity of rainfall. So here I is given as 1 cm/hour. So you don't have to substitute, that is 1 by 1 only, into d by dt of, just substitute the whatever the expression it is given in the question. 3 minus of 2 plus t into t to the power minus 2. d by dt of constant is 0, minus of 2 into minus 2 into t power minus 3 minus or plus into minus 1 into t power minus 2. 4 t power minus 3 plus t power minus 2. That means 4 by t cube plus 1 by t square. If you substitute t as 1, you will get 4 plus 1, that is 5 meter cube per second. This is the option. As coming to the next question. In a particular season, the catchment was found to has phi index. So phi index is given as 0.4 centimeter per hour. And if a rainfall of 2.4 centimeter occurs in that season at a uniform rate in a 8-hour storm, he is telling about 2.4 centimeter rainfall occurs in 8-hour storm. Let us convert this 2.4 centimeters 8-hour storm into the intensity. That is I is equal to 2.4 by 8. That is centimeter per hour. Here also centimeter per hour. That's why I am converting it to centimeter per hour. It is 0.3 centimeter per hour. Whatever the intensity coming is less than the phi index, it indicates that, you all know that phi index indicates that above phi index only runoff will take place. So he is asking the resulting direct runoff depth on the catchment in centimeter. Here intensity is only less than the phi index. So that means runoff will not take place at all. If the intensity is greater than phi index, then the what is the difference between phi index and intensity will be the runoff will take place. But here it is less than phi index, so you can say directly it is 0. It's coming to the next question. In channel routing using a Muskingum method, the value of the routing coefficient C0 C1 is given. C0 equal to minus 0.3 and C1 is equal to 0.6. What is the value of C2 is telling? We all know that C0 plus C1 plus C2 is equal to 1. Let us substitute in this, you will get C2 is equal to 0.7. Coming to the other question, convective precipitation is caused when? Here you can see in this image, convective precipitation is caused when the whatever the radiation coming from the sun, it will heat the ground surface and warm air will rise with moisture in it. That means moisture air will rise to the atmosphere, and when the air cools in the clouds, so that the rainfall will takes place. This is the concept of convectional rainfall. So here you can see, due to surface heating, rising of moisture, there is moisture will rise because of surface heating of the sun. So you can say this is the right answer. Let's come to this question. The confined aquifer of thickness 5 meter gives a steady discharge of 20 liters per second through a well of 0.3 meter radius. Height of water in the well dropped from 10 meters to 8 meters. After pumping, what is the coefficient of permeability when the radius of influence is taken as 300 meters? You all know that for confined aquifer, the formula is 2 pi kb into what is the delta H or head difference into ln r by Rw, where R is the radius of influence and Rw is the radius of flow. Let us substitute 2 pi into K. He is asking about the coefficient of permeability, so it is K. What is the width? Thickness of the aquifer is 5 meters. So delta H is nothing but 10 minus 8, that is 2 meters, by ln of radius is 300 meters and radius of well, that is 0.3 meters. And Q is given as 20 liters per second, that is 20 into 10 to the power minus 3 meter cube per second. Okay, here you can cancel 2 1 2 10 ja, 5 1 ja, 5 2 ja, 2 also get cancelled. K is equal to ln of, if you see this expression, 3 by 10 it will come, 10 will come upward and 3 will get cancelled, you will get ln 1000 by 5. And here you can see this 10 to the power minus 3 is also left, that means 10 to the power minus 3, which is nothing but 0.001 into ln 1000 by 5. Pi is not in the ln expression, pi is outside the expression, but here options are given wrong. So you can pick the answer as 0.001 ln 1000 by this separate expression, that is pi should be under this expression. This 2 is the answer. Let's come to the other question. The 24-hour rainfall of 50 centimeter magnitude at a station located in hilly terrains as a written period is T is given as 50 years. The probability having 3 succeeding years in which rainfall is greater than or equal to 15 centimeters. In 3 succeeding years, the rainfall should be greater than or equal to 15 centimeters. What should be the probability is asking. Like we are know that probability, suppose P of n comma r is equal to NCR P power r Q power n minus r. Here in 3 years he is asking how many times it will come. Like n is equal to 3 and also r should be is equal to 3. So 3C3 is equal to 1. You can take it as 1. And also 3 minus n minus 3 minus 3 will become 0. So you can forget this expression. Only P power r will be there. That is P power 3 will be there. P power 3 means 1 by 50 whole power 3. 51 ja 0.02 it will come. 2 cube 8 is 8. 10 to the power minus 2 into 10 to the whole power 3, that will become 10 to the power minus 6. You can take it as 10 to the power minus 6. 18 to 10 to the power minus 6 is the answer. Okay, that's all for today. These are all the questions from hydrology and irrigation. Hope you understand whatever I have explained. So please subscribe my channel so that I will make more videos on previous year questions of AEE also. Okay, and also Telegram channel for TSPSC and APPSC AEE is given in the description. Join that link so that you can get the time to time updates. Okay, thank you for watching.